Thanks for joining me for MTI's Whiteboard Wednesdays. I'm Dan Adams. Today we're talking about direct drive versus low force for piston rods. Today we're going to talk about the friction welding of piston rods, also known as hydraulic cylinder rods. We're going to compare the traditional friction welding process, being direct drive friction welding, to a new process that we call low force friction welding to see what benefits we might be able to gain from what is currently being done in manufacturing to what could be done as we implement the next generation technology. Hydraulic cylinder rods are near and dear to MTI's heart because our very first friction welding experience was done with Caterpillar Tractor Company, who we bought the rights and the patents for the inertia welding process from. Piston rods have been done since the mid-1950s, 1960s, and the predominant technology is direct drive. And the reason for that is we need to be able to build in enough heat into the component to be able to control the cooling rate and avoid the formation of martensite. So we do that in direct drive. We bring the eye or the clevis up to a rotating speed, the RPM. We bring on first friction pressure. This squares up the interface a little bit, reduces the coefficient of friction so that we can bring on greater load. The second friction phase is where we add the majority of the heat and we start upsetting the material. This friction phase is shown as really short here in the diagram, but in the case of hydraulic cylinder rods, we extend this time and we get a lot of upset in this phase, again, to be able to build heat in the part so that it cools at an appropriate rate to avoid the formation of martensite. Once we get the desired amount of upset, we bring the rotating spindle down to 0 speed, we bring on the forge force, and the weld is complete. But at that point, because of all the upset we created in second friction, we have to do a post-weld machining of the flash. And this two-axis machining is a very difficult process. So as you look at traditional hydraulic cylinder rod, the first thing that comes to your eye is this large amount of upset. So this flash formation has to be removed in a two-axis CNC style turning operation. And it's difficult because sometimes you have some of these little stringers that are off to the side. You have to make sure that you don't create a ring that breaks free from the rest of the flash and will then possibly scratch the pre-chrome rod. And this is a tremendous amount of cycle time. Many times it's often as long as the welding process itself. If we look at the low force process, we have the ability to add preheat so we can get the heat soak into the part that we want without having to generate all that friction or all of the upset. We can make low upset welds with this because we're using the preheat to get the heat in. So we may go through a first friction phase, we may go through a second friction phase, or we could just bring on forge force from the beginning and just handle all of that heating with the preheat side. So now our cycle times are much lower, but the biggest benefit is we may not create all that upset that then has to be turned off in this post-weld machining operation. Here's an example where we're welding a rod to an eye where the diameter of the eye at the weld interface is slightly larger. You can see this weld curl here is more of a bulge. So turning this off post-weld is much easier. We may not even have to turn it off because there's no stress riser here as a result of the flash morphology. Here's an example of a weld where the rod and the eye diameters at the weld interface are the same. Again, you can see this bulge at the weld interface instead of having that complicated curl. If I need to turn this off, I can do this with a single plunge cut instead of a two-axis move. So not only is my welding cycle time faster, but my flash removal, if necessary, is also faster. So as a result of the low force process, we're creating less upset, which means our cycle time is going to be faster. The overall equipment throughput is going to be better. So you may want to look at the entire manufacturing process. How do the incoming parts come to the machine? What happens when you're making low upset welds? What do you have to do with the parts right after? We have tighter tolerances in low force than we do in direct drive. So I'm much closer to finished components and might be able to go right into the assembly phase without having to do any flash removal or machining of the components. So we encourage customers to look at the entire manufacturing process when considering low force, as opposed to just trying to replace one piece of equipment with another piece of equipment. We can walk you through this entire process by doing some weld development with you so you can see what happens when we weld your components. And we can walk this all the way through the design and build of a piece of equipment so that you're in a position to gain all of the values associated with low force, not just replacing the equipment that you may be used to with respect to direct drive. Thank you for joining us for this episode of MTI's Whiteboard Wednesdays. For more information on this topic or other friction welding solutions, please visit our website at mtiwelding.com.